Okay. So this talk is about WebRTC. How many people know about WebRTC? Heard of it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Okay. So I'll just explain a little bit about it, what WebRTC is. I have 30 minutes and I have a lot of slides, so I'll just try to go through them as quickly as I can. A little bit about me. How many people have heard of Opera? Good, almost everyone. How many people have not heard of Opera? That's good. If you haven't, download it now. Anyways, I work in developer relations in Opera Software. I've been working here for about 7 years, almost. My main job is to talk about web technology, talk to developers especially, but also to talk to the managers and talk to the engineers, and trying to be a bridge between the developer community and the people who are actually implementing the web standards, right? And also participate in the standards building community, right? So I'm part of a few W3C groups as well, and yes, I'm already connected to Wi-Fi. So yeah, that's all about me. Now let's talk about WebRTC. So I've always been interested in the intersection between various technologies, and that's where WebRTC comes in, because if you really want to do WebRTC correctly, or if you really want to do WebRTC in a really nice way, you'll have to connect different technologies. You can't just work in isolation with JavaScript, right? You probably have to use stuff like CSS. It's very, very interesting to think about how do you use JavaScript with CSS and with the web audio API and device orientation, all that kind of stuff. And you can do really, really cool stuff with WebRTC, and especially when you combine it with different technologies. So what is WebRTC? RTC stands for real-time communications, right? And WebRTC is taking that real-time communication thing and putting it on the web. So previously, even now, whenever you have to do video chat, what do you use?
Hangouts.
Skype, Hangouts. I'll talk something very interesting about Hangouts later on. But a lot of people use Skype. A lot of people use probably WhatsApp, right? A lot of people use different technologies. None of them are really web apps apart from Hangouts, right? So that was the intention, to bring this kind of real-time communication, video chat, audio chat, but more than that also, to the web, so that all you need is a web browser. You don't need to download an app, right? So what this means is there's no plugins, right? You just go to a website and it should work. You should have video chat in that browser, right? That's all it should take, and that's what WebRTC is all about, right? So, and this reduces friction, because it reduces friction for end users, because they don't have to download anything, they don't have to install anything. Just an updated browser would work, and it reduces the barrier to entry for all these kind of communication products for various companies as well. You don't need to be a big company like Skype or something to do this, or Cisco or whatever. You can be a small startup and make a really great WebRTC solution, and I'll demo one of those in this talk. And you can create awesome things with it. Keep in mind, I'll be showing a few demos. Some of them are not really polished. Some of them are I've just made a few days ago, just to demonstrate a certain concept. But I'll be showing a few things which you might consider, that's interesting. And also the video and audio quality is really nice. I mean, especially in certain browsers, Chromium-based browsers like Opera and Chrome, you can actually do HD calling using WebRTC. The thing is, I've seen very few people actually talking about it. Most of the people who I've seen talking about WebRTC haven't really been from the web community. They've been from the enterprise community, people who have a background in SIP and that kind of stuff. Not really web developers who generally deal with CSS and JavaScript all the time. So that's why I want everyone over here to get really excited and deal with and play with WebRTC. And that's the thing. I mean, there was this recent survey in which they said, what's the biggest barrier to WebRTC adoption? And the number one thing was lack of awareness. People didn't know about it. So hopefully this talk will convince you to take a look. We need more web developers. So I'll go straight into what WebRTC is. Basically, it consists of three things. One is called media stream, the other is called RTC peer connection, and the third is called data channel. Right? So media stream is basically another word for get user media, and it deals with getting access to the device camera and the microphone. Right? Then you have RTC peer connection, which actually is one of the main things. It makes a connection between you and some other person. Right? And the third is data channel. So if you want to do some chat or if you want to send some file, then you use that. So let's look at first get user media. How many people have played with get user media? 1, 2. Okay. So get user media has actually been around for a relatively long time. Opera was one of the first browsers to actually support get user media on mobile, and I've also done a few things on get user media. Basically, it's about getting access to the device and the camera and the microphone, and it's a very simple JavaScript API to do this. If we look into the code, I hope you can see the code over here. Okay. That's the thing with resolutions. Does anyone know how to increase the font size? Command plus. Oh yeah, thanks. So this is how you use get user media. So you just say navigator.getUserMedia. And of course, this is prefixed in different browsers. So in Chromium-based browsers, or WebKit, you'll say, WebKit get user media. In Mozilla, you'll say Moz get user media, right? And you can always prefix this over here. Have a string for the prefix, right? And then what you have is you have a constraints object, right? In that constraints object, you'll say, okay, whether I want the video or the audio or both, right? And the second thing is the success function, this thing over here. So if the user gives you access to the device camera or the microphone, then this is called. And if he doesn't, or there's some error, then this is called, right? So we're interested in the success function. What happens? Basically, you get access to the device stream, the camera stream or the microphone stream, right? And then you create a URL, object URL, and you have a video object, like the video tag, right? You have an empty video tag, and you assign that to the stream. You assign the stream to the video object. That's it. So if you want to see a small demo of how it works, let's go over here. In every browser, it will first ask you whether you want access, want to allow access to this web page for the device camera or the microphone. If you click allow, then yes, you can see, right? And of course, you can have different constraints as well. Right now, it only works in Chromium-based browsers. You can do HTTP. So the constraints over here is video, audio false, and video I say minimum width 1280, minimum height 720. So if I refresh this, I'll have bigger resolution, right? So this is basically how it works. Let's go back. So what can you achieve with access to the device camera and access to the microphone? Does anyone have any ideas, like what would you do if you have access, as a JavaScript developer to the microphone or the camera? What could you do? Anyone? Any hacks? Any kind of fun stuff? Yeah?
If we had two cameras, we could use a stereoscopic effect. We could create that like 3D virtualization, virtual reality. If we are viewing it using a 3D glasses or with cross-eyed 3D eyes, then we could use those two images to create a 3D.
That's pretty nice. Anyone else? Okay, I'll show you a few things. Remember I said that you can combine this with various technologies. So you can actually combine it with stuff like CSS. How many people know about CSS filters? CSS blend modes. I actually wrote an article on CSS blend modes on DevOpera. Just go to dev.opera.com and over there you'll probably find it. And how many people know about CSS masking? Okay, so there's a small demo that There's a small demo that I made which demonstrates how you can get user media with various filters, various effects. For example, over here you have all the various CSS filters. So you can blur, the camera in real time. You can make it black and white. You can invert it. One fun thing is your teeth look super scary. Also, you can have CSS mask, so you can make this a circle very easily. Right? Of course, you can actually have various blend modes as well, like multiply. Yeah, so you can have these different blend modes over here. So this looks pretty nice, right? So you can combine and make the video a little bit more fun, right? And send it to the other side as well. So this is pretty nice. That's not the end of it. Let's go back. You can also, take actual photographs. You can record audio, do audio visualization with the Web Audio API. How many people know about the Web Audio API? Yeah. Let's see if I have a demo for that. So let's see if it detects some kind of uncharacteristic sound. So everyone just remain a little bit quiet. Go on, quiet. These demos always work a little bit weird. But in my quiet room it used to work. But you can see over there that I used the Web Audio API to actually get live audio, and then I used it to create a graph of the frequencies of whatever sound is coming in, right? So that's pretty good. So yeah, you can theoretically do something like, a clap-powered interface, or detect some kind of sound like a grunt or a or something like that, and do some kind of action using that. It's pretty nice for accessibility as well, if you want. But you can do a lot more stuff as well. Like you can do, you can capture video, make a GIF, animate a GIF for it. You can do motion detections. Some people have actually done this. They've made a security cam using the camera axis. So if something stays still, then it's fine. But the moment something moves, an alert will be fired to some kind of service, right? I also made something which is a little bit similar, which is this one, if I'm correct. So on the left, you can see that if I'm moving, it detects it. One more thing is, and this isn't really done yet, is if I click this, might So you could do something like this, like an airboard or something like this, using just motion detection and normal, computer science concepts, and combine it with get user media. So that's pretty nice. I didn't click anything. I just pressed on A and it worked. Anyways, so yeah, you can have like hotspots like on the corner of a particular webcam. If you click on the if you place your hands on the corner somewhere, then certain action happens. You know, some people have actually even made an emotion detection algorithm, and you know, using JavaScript and Get User Media. So if you smile, it'll detect that you have actually smiled. If you frown, it'll detect that you've actually frowned. So you know, that kind of stuff is really, everything related to computer vision is now available to JavaScript developers, which is really, really nice. Let's go on. One more thing which sometimes gets people is, you know, getting permission isn't easy. You know, you have to allow access to the camera and stuff, and sometimes people don't see it. So some services take the extra effort to actually make the user notice the permissions dialog. Like for example, you know, this is one service called GoToMeeting. It actually points above like this to enable to make the user notice that there's some permission above. And in Firefox, it actually makes this diagram that says click over here. So you know, people actually notice it. This is another service called Appear-In that I'll demo later on, which also does the same thing, kind of like points an arrow saying, okay, click over here, notice this. Because many people don't actually notice it. And this is in Opera. But there are some concerns, like even though this is really, really cool, there's some things which are not, you know, we still need a few more things. Like for example, in Get User Media, you cannot use the device flash or you know, low light, something like that. You cannot auto zoom, you cannot auto focus as such. You know, there's another. I'm a part of the standards process, and I kind of discussed this thing back in 2011, in which I said that you know we need access to this, and unfortunately I didn't really get that much support at that time. There's another API called the HTML Media Capture API, which kind of is a halfway in between. So with there, they've extended the input tag to include the word capture. So if you say input type file except image, start, and capture, then the moment someone clicks on this, it will open up the native, you know, the native application in which you can use the camera or the gallery to take a screenshot or you know select a photo. So you can kind of do this, you know, using, and once you have the native application doing this, then you can obviously use auto zoom and stuff like that. So this was Get User Media, you know, having access to the device camera and microphone. But the other thing is the RTC peer connection. You know. WebRTC is supposed to be peer-to-peer, which means, you know, once the server helps you form a connection, it goes out of the way. You know, it's completely between you and some other person. There's no server in between. Okay. So let's see how it works. So generally speaking, whenever two computers want to connect, they can't really connect just like that. Right? They're generally between, you know, there might be some kind of cell tower in between. You know, you might have a router in between. You might have some other things in between. You know, these are sometimes called NATs. How many people are familiar with NATs? Okay. So some kind of big proxy of files is connected. Then it'll have an internal IP for you and a public IP, like that. So you can't really just connect to someone else. You know, you need to do some kind of NAT traversal. Right? There's a whole handshake process that I'm going to talk about. So before that, there are three things that you need to learn about. One is called stun. Right? It's used to get basically your public IP and your port. Right? There's a stun server. I kind of make a small ping to it, and it kind of, the stun server kind of gets your public IP and port, and then you can do whatever you want with it. So stun, it generally works around 80-85% of the time, but sometimes it doesn't. So for those cases, you actually need something called turn. So turn servers are basically relay servers. They include a stun server, and if the stun protocol works fine, if not, then it uses the turn protocol. So basically what it does is it basically takes whatever you are giving and sends it to the other side, right? So if if a turn server is used, then proper P2P will not happen because the server will always be required to relay stuff to the other end. But generally around 80-85% of the time, it's not required. Only stun is required. Right? So what happens? WebRTC doesn't really define how you do signaling. The signaling part is the part required to actually make a connection, right? So it doesn't really say what backend server you use. You can use WebSockets, you can use Ajax, you can use SIP, you can use carrier vision if you want. What it does is say is a certain set of protocols are needed, a certain amount of steps in a particular order are needed, right? So first is the concept of a SDP. So you have something like a local SDP and a remote SDP. Local is yours, remote is someone else's, right? So the SDP basically has information about what codecs you support, what kind of CPU parameters do you have, right? All that kind of stuff which is needed to form a proper connection, right? You have that. Then it creates an offer and it's sent to whatever backend service you have, whether it's a Node.js running WebSockets or Ajax or SIP. The other person connects and it receives the offer and sets its remote SDP based on the offer that it had. Then it creates its own answer based on its own local SDP, sends it back. The first person receives it, sets its remote SDP. Now both have the remote and local SDP set. Now some connectivity checks happen. This is called the ICE candidate process. And then a P2P connection is established, right? So this is the entire handshake process for WebRTC signaling. There's also something called trickle ICE, which generally increases the speed in which this happens because there are certain parameters which you can send right away. You don't have to wait for the remote and local SDP all the time. So yeah, to have a demo of this, let's see. I just made this very recently, so it may or may not work. But let's try it if we can. If it connects. That's right. So this is an actual live P2P connection happening using WebRTC. Proper video chat inside a browser. One is this, say hi, and the other is this one over here. So you can actually do this, and it's relatively simple. Once you know the steps, it's actually pretty simple to do this. There's another site, an actual production site called appear.in. So let's go over there. Let's create this room. Can someone else on Chrome or Opera or Firefox just go to appear.in/Wingify? Anyone? Let's see who it is.
How many we can support? How many we can support?
I'll come to this just after this.
Alright.
Hey, who are you? Hey. So you can actually support, theoretically you can support kind of unlimited, but really not. So what happens is, every time you make a connection, it has to form like a connection between all of you. So if it's like you and someone else, then it's fine. But if it's like 3 people, then one person has to form a connection with n-1 amount of times, right? So every time a new person joins, the load on the CPU gets increased, right? Because n-1 number of times you have to do the same thing, right? And manage the streams and everything else. So practically speaking, in most cases, it's around 4 or 5 people you can generally have a very nice conversation with. Afterwards, depending on your CPU, the performance can lag pretty seriously. Right? A peer tin officially supports 8 people, but generally it's like 4 or 5 people can talk.
So like for every connection there is a different port that has to be freed.
Not really. For every connection, you actually have, every connection is encrypted first of all, right? And you have to manage each and every stream. So if you have like 3 or 4 HT streams, for example, and you're doing it all in your browser, right? Then it takes a lot of resources to actually maintain that. Right?
Yeah, I'm getting that. You said that first, before that process, we have to find out the public IP and the port.
Yeah.
Right? So for every new connection, we need a new port.
Yeah, of course. Yeah. I mean, if you're on the same IP address and port, then that's your same device, right?
No, but can't that be done using the same port? But all the data is going through the same port.
Not on one side. You have to have like different things. You have to have a different. In the end, you have to have a unique IP address and port to connect to a unique particular device. Right? That is required. So yeah. The third is data channels, right? So data channels are very, very simple. How many people know about WebSockets? Or played with WebSockets, right? So data channels work almost completely like that, right? It's by design. So, but the good thing is, with data channels, you can send a string or a JSON object or even binary data. So for gaming, it's really, really great. And the advantage over here is since it's P2P, it's very high performance, has very low latency, like seriously very low latency. So that's very good. They have 2 modes. One is reliable TCP. For example, if you're doing chat or file sharing, you want it to be appear in a particular order, right? And unreliable, for example, games. If you're pressing forward, it doesn't matter whether the first request comes or it comes in a different order. If you're pressing forward like 20 times, then you just want to send it as quickly as possible, right? So, and you have ordered, you have different options like max retransmit times, maximum amount of times you want to try sending something before it fails. One more thing with data channels is it doesn't require a permission UX like get user media does. And the second thing is it's bi-duplex. So once you open a data channel, both you and the other person can start sending and receiving data at the same time, right? So that's pretty nice. The code works a little bit like this. You say peer connection, new peer connection, then you have our data channel. It's called peer connection, but create data channel. That's it. You have a name for the data channel. In this case, it's my data channel, right? Then you have on message. If a new message comes, then do this, and then send function to just send a particular thing. It's very similar to WebSockets. It's pretty much the same. Right? So these are the main functions for data channel. It's actually one of the most underestimated uses for WebRTC. There's a particular project called PeerFlix, which is used in popcorn time. How many people know about popcorn time? So it actually uses something called with WebRTC data channels. There's something called peer CDN. So it's an actual CDN in which it connects to resources in a peer-to-peer basis. So if you want to fetch a resource, it checks whether whether one of your peers actually has that resource. So instead of connecting to the internet, it'll just connect to the other peer and download that resource over there. There's also a project called WebTorrent going on right now, in which they want to use data channels to create like a full-on torrent, right? And that's pretty cool. So these kind of things, of course, you can do file sharing, and all that kind of stuff using data channels as well. So all of this is possible using WebRTC. Browser support. So right now there's a site called iswebrtcreadyyet.com. It lists the amount of browser support there is, what particular functions are supported, which particular functions are going to be supported, right? And there's since RTC peer connection is actually prefixed between link-based browsers like Opera and Chrome and Mozilla, there's a particular library called adapter.js, which kind of like is a shim to make sure that you just use the normal unprefixed version, and it's going to automatically take care of the prefixes between Firefox and Chromium-based browsers. Right? So what's next? Better echo cancellation. Echo cancellation is really important when it comes to making video calls. Right? So the echo cancellation right now is good, but it can be improved, and that is done on the browser side. That's done on the engine level. You don't take care of it, the browser does it themselves. Noise reduction as well, especially for smaller cameras. So if you have a really nice big full HD camera, that's fine. But if you have a really small camera, then there's a lot of noise going on in between. So the engine also wants to take care of that. How many people know about VP8? So the codec which is being used, especially on the Chrome side for this is VP8. There's also talk going on using VP9 now. There's an API called Media Stream Recorder to record live video. You might wonder how does this, it manages bandwidth. Like someone is on a slow connection, someone is on a fast connection. Once again, that stuff is handled by the browser. It has an internal engine called the bandwidth estimation engine, which kind of takes care of it. And one more thing is like per stream bitrate control. If you want to take control of how much should be the bitrate for a particular stream, right now it's not possible. But there's another standard going on called WebRTC, which is probably going to be WebRTC 1.1 in the future, and that will have per stream bitrate control. So yeah, when it comes to browser support, right now MS and Apple are not playing well with WebRTC, but the next version called WebRTC or WebRTC 1.1, Microsoft is one of the editors, and it's expected that they will probably support that version. And of course, you'll have a shim to take care of backwards compatibility so that your existing WebRTC applications are not affected in any way. So yeah, that's all there is for WebRTC. If you have any questions, sure. Cheers. Any questions? Any kind of questions regarding WebRTC or Opera or anything?
You told me something about Hangouts.
Oh yes, about Hangouts. So if you're using Hangouts right now on Chrome or Opera or even Firefox, right now it uses WebRTC. It doesn't use the plugin anymore. It's a very recent news. So you already use probably WebRTC in your day-to-day lives as of right now. So that's pretty nice.
What's the current browser support for WebRTC?
So the browser support is over here. There's a site called is WebRTCReadyYet.com over here. It lists the in detail what the browser support is. In short, the newest versions of course, newest versions of Opera Developer as well as Chrome Canary and Firefox or whatever, they'll have the new support, right? But Apple and iOS in general, that those browsers don't have support for it right now. But it's expected that they will in the future. They'll probably take the stuff which is inbuilt in Link and just put it in. Okay. With Microsoft, they're probably not going to support WebRTC 1.0, but 1.1 they'll probably support. I mean, that's the indication right now. I think I said it's wrong, but that's the indication.
Can you explain the turn server again?
TURN? Can I explain it? Okay. So you use a stun server, right, to get basically the IP address in the port, right? And if you have that, and if you make the connection, it's fine, right? Great. But a lot of times people are, in very, very tight and strict firewalls and enterprise kind of offices and stuff, which is very, very restrictive. So sometimes around 14-15% of times the stun protocol will not work, right? So in those cases, as a fallback, you'll have turn. You'll have a separate turn server, right? It's RFC 5766, I think. And there's an open source turn server available, which you can install on Amazon or DigitalOcean or something, right? And using that server, it'll be like a fallback, right? So in case that doesn't work, it will act as kind of like a turn between you and the other person. So basically the whole funda is that if turn doesn't work, turn will work 100% of the time, theoretically speaking, right? But the catch is the connection will not be P2P, because what it will do is it will take the stream from one side, right, and relay it to the other side, right? It won't work peer-to-peer. It will use the turn server as a relay server, right? So it'll just relay information from one side to the other, right? So that's the
Shwetank?
yeah. Right.
Actually, I experimented with WebRTC when it was early beta in Chrome. And what was I trying to do is we were building a small POC to sustain somewhere around 5 to 10 people in a room. So up till now I've been chasing WebRTC. What new into that part is my understanding there is something called MCU. So is there any development in your knowledge? What is the latest in MCU part, and is there anything open source which you would like to suggest?
Well, the thing about MCUs is this is not my expertise, right? But an MCU is generally needed if you want to do connections with a lot of people, not just 5 or 6 people, but a lot of people. And also it helps in transcoding, right? So if one browser only supports, say, H.264, the other person only supports web, and then you can do transcoding on the server side to convert it from one format to the other, that kind of stuff. Generally speaking, for you guys, it may not be required, but for large applications which want a large number of connections, it might be required.
So is there any suggestion on MCU, any open source version you know?
I'm completely clueless on the particulars of the MCUs.
Okay.
I know what it does.
Okay, sure.
But I can connect you with a few people who are looking at it.
Sure, thanks. We'll touch offline. One more question about Opera. Do you people have something like Node Backend, whereas we can use Opera as a kind of a platform to build desktop applications in JavaScript? I'm sure you know about that, Node Backend.
Yes, I'll talk to you offline on this.
Right.
Yeah. So, any more questions? Right. So, thank you so much, and I hope you are a little bit more excited about WebRTC and willing to play with it. Thanks.